Hello, geometry friends. Here we go, the moment you've been waiting for, this June 2017 exam. I'm sure made you feel real good about yourselves, right? It was a tough one. Don't forget to subscribe to our channel on YouTube. And here we go. So, June 2017, this was a rough one for a lot of people. First few questions aren't bad, I promise, but it gets a little tough as the time goes on. So in the diagram below, triangle ABC is congruent to triangle DEF. Which sequence of transformations maps ABC onto DEF? Well, clearly, in order to get over to here, it has changed orientation, right? This vertical side is on the left and then over, or on the right, and then over here it's on the left. So there is definitely a reflection involved. Reflection. Okay. So we're going to reflect over the y-axis here. So it looks like the only one that says reflection over the y-axis is actually choice 2. And then after we reflected over the y-axis, in my beautiful drawing skills, we would just translate down. So that would be choice 2. All right, number 2. This actually isn't a difficult question, but it was a time-consuming one. You had to actually do some things here. You could have actually done the distance formula. This does end up being a right triangle, so you could do the distance formula for PQ and the distance formula for QR and do area as 1/2 base times height. I didn't do it that way. I just created a rectangle around this, so I drew a straight line here and here and then up here. So I'm doing this using very straight lines. So I know the area of that rectangle is 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know the area of the rectangle, that's a rectangle, is 80. And then to find the area of the triangle, I'm going to figure out the areas outside there and subtract. So, I don't have my right answer key open up here. I don't have mine. Hello. Sorry. Okay, so this triangle has a base of 1, 2, 3, 4, 5, and a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 50, but half of 50 is 25. This triangle down here, this little one on the right, 1, 2, 3, 1, 2, 3, 4. So 3 times 4 is 12, half of 12 is 6. And then 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. 6 times 8 is 48. Half of 48 is 24. So if I add up these three numbers, I get 55. So 80 minus 55 is 25. So like I said, you could have done the distance formula and figured out the base and the height of the triangle. And actually, you could have done it this way. This right here is 5 because it's a 3, 4, 5 right triangle. And so that's 5. And then the height, and I got to see how my friend did it here, is 10. So P to Q is 10. So base times height, 5 times 10, half of 25, or half of 50 is 25. So either way, you could have gotten that right. This question keeps showing up on every test, so if you don't know this, I would put this on a flashcard or write it out like 1,000,007 times to make sure that you know this. This keeps showing up in every way, shape, and form on these geometry tests, so you want to make sure you're good at it. It says in right triangle ABC, the measure of angle C is 90, so we're dealing with a right triangle. The cosine of B is 5 over 13, which function also equals 5 over 13. Well, you're supposed to know that in a right triangle that the sine of angle A would be equal to the cosine of angle B. That's what they're saying. So if they're saying the measure of angle C is 90, the sine of angle A is equal to cosine of angle B. Not that those angles are equal, but these two angles add to 90. So it should be sine of A, right? Yeah, choice 3. It's called the complementary, I don't even know. It's funny, I keep calling it the complementary angle theorem. I think it's the right triangle complementary angle theorem, but that's something you need to know, okay? All right, next page. I'm gonna take a break here. All right, so number 4 is just a circle property, and I think you know this one. An inscribed circle, or an angle inscribed in a circle, so inscribed means it's on the circle, is equal to half the arc across from it, okay? So that's what they're asking about here. It tells you, though, that arc A, B, C, this direction is 268. You know that a circle is 360 degrees. So you go to your fancy calculator and you, oh, it's not even open. I am sorry about that. Let's just do the math here. 360 minus 268 is, you're just going to have to trust me on that, 92 degrees. And so half of 92 is 46 degrees. Sorry, I wrote that like a giant. We got it there. All right. Number 5. Given triangle MRO shown below with trapezoid, PTRO, M to R is 9, great. M to P is 2, got it, and P to O is 4. It wants us to find TR, which is this little guy right here. Okay, making a new pen. Well, I like to do the whole thing and then the piece I'm looking for. That whole side is 6, right? So I set up a proportion of the big triangle, 6, over the small triangle, 2, is equal to the big triangle, 9, over the small triangle, x. That's going to be this piece, okay? Cross multiply, 6x equals 18, so x is equal to 3. Well, if that part is 3, then that means T to R is 6. There you go. All right, let's go down here. Number 6, a line segment is dilated by a scale factor of 2, centered at a point not on the line segment. By the way, this comes into play later. Which statement regarding the relationship between the given line segment and its image is true? Okay, stop, freeze. You should know, fact. If you dilate a line centered at a point not on the line, the image is parallel to the original. So the only thing that changes is the y-intercept, because if they're parallel, they have the same slope. So same slope, different y-intercept. So let's read the options. The line segments are perpendicular. That's not it. The line segments are perpendicular. That's not it. The line segments are parallel, okay? And the image is twice the length of the given line segment. Let's see. Scale factor of 2, so times 2, okay? Or the line segments are parallel and the images is half. Well, we multiplied by 2, so it's double the size. So choice 3. Okay. Which figure always has exactly 4 lines of reflection that map the figure onto itself? Well, this would be, what you're looking for is a regular polygon. There's the word I'm looking for. And a square is regular, and it's 4 lines of symmetry. 1, 2, 3, 4. 4 lines of symmetry, so four lines of reflection that map it onto itself. It's not true with a rectangle. With a regular octagon, you would have more than 4, so it's not that one. An equilateral triangle, you would only have 3, so it's not that one. It has to be the square. Okay. Number 8, be careful when you read this. I misread it the first time, so just be careful. In the diagram below of circle O, chord DF bisects chord BC. So DF is the pair of scissors, so it's cutting BC. It cuts BC at E, so BE is congruent to EC, okay? Those are congruent pieces. B to C, the whole thing is 12, which means each piece is 6. F to E is 5 more than DE. F to E is 5 more than DE, so I'm going to call DE X, and I'm going to call FE X plus 5. The property that you need to use here is part times part is equal to part times part for the chords. So the part from D to E times the other part from E to F. So X times X plus 5 is equal to C to E times E to B. So 6 times 6. So we have, let's distribute here, x squared plus 5x is equal to 36. This is quadratic, so you have to get it set equal to 0, and then you need to factor. So I'm going to subtract the 36 over to the left, set it equal to 0, and I can factor. Two numbers that multiply to be 36, multiply to be negative 36, and sum to be positive 5. Well, I know it's not 6 and 6. I know it's not 2 and 18. So then try 4. 4 and 9. 4 times 9. 4 plus 9. Okay, well, one of them has to be negative. So if it ends up to be positive 5, then it's negative 4 and positive 9. So that checks out. So x minus 4 times x plus 9 is equal to 0. Then you get your little factors. X is equal to 4. X equals negative 9. Okay, so if x is 4, don't circle the choice, read the question, then F to E is x plus 5. So that is equal to 9. So that's choice 2. Cool. Oops. All right, Kelly is completing a proof based on the figure below. She was given that angle A is congruent to angle EDF. Angle A is congruent to angle EDF. Those are the same. And has already proven that A to B, this piece here, is congruent to D to E. Okay, this piece here. Got it. I'm actually, okay, so which pair of corresponding parts and triangle congruency method would not prove that the two triangles are congruent? I want to see what I did here in particular, what I wrote. Okay, does not prove. So, okay, what if we got, and I'm actually going to redraw this triangle because it's annoying me that it's the wrong way. I'm going to draw it like this. F is up here, D is here, E is here, angle is there. This side is congruent to this side. Okay, if we were to say that AC is congruent to DF, we would have side, angle, side. That's a congruency theorem, so we're good. So that one works. Side, angle, side, true. That one's true. We're looking for not, okay? So it can't be that choice. BC congruent to EF, so I'm going to use, okay, this one. BC congruent to EF. That would give you angle, side, side. Angle, side, side. And this says SAS. That's not right. So this is false. So that would not prove that they're congruent. to double check yourself and to be confident about your answer, continue on here. I'm going to erase the marks that I made so far. Uh-oh, these ones are going to be tricky to erase because that always happens to me. Okay, so let me redraw that triangle really quickly. I would always double check these, okay? So what about angle C and angle F? That would be angle side. Yep, that would be true. What about CBA? CBA, okay, I'm going to do those in purple. CBA would be, oh, I guess blue. And FED would be that one. So it would be angle, side, angle. Oh, that would be true as well. So yeah, I did answer it correctly. Okay, number 10, a lot of things going on here. A very messy picture, but you've got it. DE divides AB and AC proportionally. Okay, got it. So that means that DE is parallel. If they're, right, parallel. So those are parallel, which means I can use parallel line angles, which is awesome. So I've got alternate interior, alternate exterior corresponding. I'm missing one. Anyways, so it says the measure of angle C is 26, got it. Angle A is 82, got it. So if those are 82 and 26, this whole triangle, right? Big triangle ABC, 82, 26, I can figure out angle B. I can do 180 minus 82 minus 26. So let me go here, 82, oops, 180 minus 82 minus 26 is 72. I've got 72 degrees left for angle B. Okay, what else can I figure out? DF bisects BDE. DF bisects this angle. This angle has two congruent pieces. Okay, what else do we know? Well, that whole proportionally thing tells me right away that corresponding angles are congruent. So the angle at E, that's 26. That this angle right here at D is 72. So now I know that these three are supplementary, right? So 180 minus 72 is 108. So this angle right here that's bisected is 108 degrees. So half of 108 is 54 degrees. So D, let's see, this is 54, this is 54. We're looking for the measure of angle DFB. DFB, this angle right here. So we've got 54 and 72 are used, so let's go here. 180 minus 54 minus 72 is another 54 degree angle. So that little red piece is 54 degrees. DFB. Okay, so number 11 is actually really mean. This is a hard question, and you went with what you were taught, that you are supposed to be as least specific as possible. So if you got this wrong and you said that it's 1 and 2, I think that's the one, then, or 1 and something, I forget, then you were doing the right thing for what you thought it was. This was actually really specific, and so you really had to pay attention to what they were saying and draw some pictures. This was a tough question. Which set of statements would best describe a parallelogram that can be classified as a rhombus? So every one of you probably drew a picture of a rhombus because you were taught to draw a picture, and to the best of your abilities, right? So a lot of times our pictures, especially in multiple choice, are not great. So we know in a rhombus, all four sides are congruent, opposite sides are parallel, diagonals bisect each other. So diagonals are perpendicular bisectors of each other. We know that that's true about a rhombus, or we should know that that's true about a rhombus. Okay, yes, that would be, whoops, that is true. So this, oh my goodness gracious, what's going on? Those two pieces are the same, and these two pieces are the same. So I know that that's true. Okay. Oh, I didn't put my little right angle in there. Got it. Diagonals bisect the angles from which they are drawn. Yeah, true. We know that the diagonals bisect the angles. The diagonals form four congruent isosceles right triangles. Well, in the picture that I've drawn, these are not isosceles because my diagonals are not congruent. But a parallelogram that can be always be classified as a rhombus, in particular, is the square. And in a square, I know this is mean, like I said, it's mean. And in a square, if you draw the diagonals, we know the diagonals are congruent and they bisect each other. So we know that all of those little pieces in the middle there are the same. So we do have four congruent right triangles if it's a square. And because that's true, it has to be 1, 2, and 3. I'm sorry that you got it wrong. If you got it wrong. Okay, the equation of a circle. What are the coordinates of the center and the length of the radius of the circle? All right, so this is actually one of my favorite questions. You do need to know how to do this. You had to complete the square in algebra. You use it this year for circles. You will use it again next year in Algebra 2 for quadratics and circles. So just make sure you know how to do this. The number that we add when we complete the square is b over 2 squared. Just FYI to you. So my first piece of advice to you is to what I call, oh my word, my brain is not operating correctly. Just like reorganize everything. So the x and then the, and there's no other x term. So x squared I want by itself. And then I'm going to leave some space, plus some space. Y squared minus 12y, and then leave some space, equals, and bring this 20 over to the other side, so negative 20. I'm going to complete the square with the x group and with the y group. So in the x group, it's just x squared. There's no b term, so the b value is 0. Well, 0 over 2 squared is 0, so I'm adding 0 to that group. I'm going to write it just as a placeholder, okay? So that's why the center has coordinates of 0 here. The y group, you take this number, negative 12. Negative 12 divided by 2 squared. That's negative 6 squared is 36. I'm going to add it to the left, and because it's an equation, I have to keep it balanced and add it to the right. So now I'm going to factor my groups. X squared is just x squared. This group, what two numbers multiply to be 36? And sum to be negative 12. Negative 6 and negative 6. So your factors are y minus 6, also known as y minus 6 squared, is equal to negative 20 plus 36 is 16. So the center of the circle, there's nothing with the x here, so 0. You change the sign of the number inside the parentheses with the variable. So negative 6 becomes positive 6. And then the radius, okay, this number is the radius squared. So if the radius squared is 16, then the radius is 4. So the radius is 4, the coordinates of the center are 0, 6.